Question number 14, we want to show that this is AB, the vertices of a right angle. 3, 1, 1, 2, 2, 4. Okay. The plan is, first of all, if they are not either ABC in a line, or if it is not line, then it has to be in a triangle. So we can check AB gradient and BC gradient and AC gradient. If they are different, then so they are not collinear or not in a line, then we want to show that when you multiply by 2 gradient give a -1, then it is perpendicular, then it has a right angle. So this is the plan on this sum. Gradient AB equal y1 minus y2, 2 minus 1, x1 minus x2. This is going to be 1 over minus 2, minus half basically. Gradient BC, 4 minus 2, 2 minus 1, 2 over 1, gradient 2. Gradient AC means 4 minus 1, A and C. 4 minus 1, 2 minus 3. This is 4 minus 1, 3, 2 minus 3 minus 1. This is going to be minus 3. Now I can clearly see that 3 gradients, hence ABC is not only linear. There are three different gradients, hence they are not on a line, or they are collinear. Then okay, so they are not collinear, hence ABC is a triangle. I can see this 2.5, so I'm going to get that one. Gradient AB times gradient BC is minus half times 2 is minus 1. Hence AB perpendicular to BC. Hence ABC is a right angled triangle. Question number 15, we want to show that this quadrilateral is a parallelogram. So to show a parallelogram, what we want to show? We have two options. We can show that two lines are parallels. Opposite lines are parallels basically. Or we want to show that when you take two lines, they are parallel, right? Also their distance is equal. You want to show that they are parallel and that two line has to be, distance should be equal. So then it is also accepted to show that that quadrilateral is a parallelogram. We have two options. Either we want to show that two sides are parallels, opposite sides are parallels, like this one parallel to this one, and this one is parallel to this one. Or I have to take two sides and we want to show that this one parallel and also the distance is same. Then that is also we can show a parallelogram. So you can choose any method. Right. When you show this one, okay, assume that we show parallelogram, then it could be a parallelogram or it. So the same concept available in what? Square, rectangular. Rectangular also parallel and two side all the opposite side are same. Right? Square also it is same. If it is become parallelogram, we want to show that this angle is not uh, 90 degrees. If we show that one angle is not 90 degrees, then that's fine. We want to show that no 90 degrees. So because they have 90 degrees, so we want to check that when you multiply by any, two together will not make a 90 degrees. So make it gradient in terms of gradient. It doesn't equal to -1 when you multiply the gradient. Right, we'll go with this one. To find gradient is easy, so we'll stay with that. Uh, gradient AB. Gradient AB is 4 minus 1 over 2 minus 1. 4 minus 1 is 2. 2 minus 1 is 1. So it is going to be 3. Gradient BC. 4, 5 minus 4 over x minus x2. 6 minus 2. 1 over 4. JCD. 2 minus 5 over 5 minus 6 minus 3 minus 1. It's going to be 3. And JDA. 2 minus 1, 5 minus 1 equal 1 over 4. Now from here you can see GAB equal GCD. Hence AB parallel to CD. Then BC equal JDA. Hence BC parallel to DA. Hence ABCD is a parallelogram. Parallelogram, or it can be, if we have this quality, rectangle or a square. Now we want to show that we can GAB times BC, or we can explain that when you look at how many, so 3 and 3, so we have one gradient 3, other one is 1 over 4. There are no other gradients, hence 3 times 1 over 4 not equal to -1. Hence there is no right angle. Hence ABC is a parallelogram. Parallelogram. Question number 16, we want to show that ABCD is a rhombus. First of all, we'll show that it is a parallelogram. As earlier, sides are equal and no gradient make 90 degrees, and it's a parallelogram. Then we want to make a rhombus. Rhombus we will get usually when we angled a square. So it means all the sides should be equal. Then we want to find AB, BC, CD, DA distance. We can tell that they are equal. So we have to do first of all we want to show that four sides are equal, four sides are parallel. So two sides are parallel each other, and not four. And yeah, we'll work on it. Gradient AB is 4 minus 1 over 5 minus 2, which is 3 over 3 is 1. Gradient BC is 1 minus 4 over 4 minus 5 minus 3 minus 1, which is 3. Gradient CD mean minus 2 minus 1, 1 minus 4, this is minus 3 over minus 3, which is 1. Gradient DA mean minus 2 minus 1 over 1 minus 2, this is going to be minus 3 over minus 1, which is 3. Now we can see those two are parallel. So GAB equal GCD. Hence AB parallel to CD. GBC equal GDA. Hence BC parallel to DA. Right. Then so we have two set value gradients, 1 and 3. So 1 times 3 not equal to minus 1. Hence no angle is perpendicular. Hence ABCD is a parallelogram. Parallelogram or square rectangular. Sorry, it's a parallelogram because we show that it is no rectangular, it is a parallelogram. Parallelogram has no right angle. Angles exist. Now we want to show that all the sides are same. So we have to do a kind of a calculation. Distance of AB x1 minus x2 square plus y1 minus y2 square. So this is going to be 2 minus 5, 3 square, 9. And 9, this is going to be 3 square, 9. I think this has to be 2. I think I had to work all the sum again. Let me see. So Gradient AB is 2 minus 1, 5 minus 2, that is 1/3. Gradient BC equal, this has to be minus 1. So somehow it works. The previous one accidentally. Can't believe that. So BC, so minus 1 minus 2 over 4 minus 5, which is 3, and gradient BCC CD is minus 2 minus 1 CD minus 1 plus 1, 1 minus 4, this is going to be minus 1, this is going to be minus 3, which is 1/3. Gradient DA equal minus 2 minus 1, 1 minus 2, this is going to be minus 3 over minus 1, 3. So AB parallel to CD, and BC parallel to DA, and also third times 1/3 not equal to minus 1, hence ABCD is a parallelogram, as there is no right angle. This is checking for right angles. Now I want to show that these distances are equal to become a rhombus. DAB equal x1 minus x2, 5 minus 2 square plus 2 minus 1 square root. This is 3 square 9. This is 1 square root 10. DBC mean 4 minus 5 square. Then plus minus 1 minus 2 minus 2 square root. This is 1 and this is 9 square root 10. DC is CD is 4 minus 1 square plus minus 1 plus 2 square. So this is going to be square root 10, 3 and 1, and this is DA 1 minus 2 square plus minus 2 minus 1 square. This is minus 1 square, this is 3 square root 10. If I get to square root 10, other has to be square root 10. I don't need to worry much, but the calculation should be equal. Hence, all the sides of ABCD parallelogram are equal. Hence, ABCD is a rhombus. Minus 5 2, minus 3 minus 4, 3 minus 2, question number 17. So first of all, we show that they are not collinear or not in a line. So gradient AB is minus 4 minus 2 over minus 3 minus 5, which is minus 6 over minus 2. which is 3. And gradient BC mean -2 minus minus 4 over 3 minus minus 3. This is going to be -2 plus 4, 2 over 6, 1 over 3. A, B, B, C, C, A. -2 over 3 minus minus 5, which is -4 over 8, which is minus half. Hence, GAB not equal to GBC not equal to GCA. Hence, ABC is not collinear. Hence, ABC is a triangle. Now, there should be a 1 is minus. Right should be a right angle, but no one multiply will give a right angle. Okay, so there should be something error here. -3 minus 5 plus 5 mean, so plus 2. It means -6 minus 6. Right now, GAB times GBC equal -3 times 1 over 3 minus 1. Hence, AB is perpendicular to BC. Hence, ABC is a right angle triangle. TRI. So in that case, this is right angle. A, what is the common letter B? So then it has to be BAC. Then I want, so isosceles, then AB and BC, I need to check the distance. Not AC is going to be the hypotenuse. So let's look at AB. -3 minus minus 5 square plus -4 minus 2 square. This is going to be 36, and this is 4 square, 40, square root 40. Distance of BC equal -2 minus, sorry, 3 minus minus 3 square plus -2 minus minus 4 square. That is also should be 40. No need to check, but we will check the calculation. 9 square, yes. Hence, DAB equal DBC. Hence, ABC is a right angled isosceles triangle. Question number 18. There's a circle and there is a line. There are two intersection points. To have two intersection point, we have to be b square minus 4ac has to be greater than 0 when we solve the equation. So we'll start solving this. So this is 1 and this is 2. From 1 and 2, so x minus 1 square, y square mean ax square equal k. So this is going to be x square minus 2ax plus 1 plus a square x square minus k equals 0. Now x square plus a square x square minus 2ax plus 1 minus k equals 0. Now this is 1 plus a square x square minus 2ax plus 1 minus k equals 0. Right, I'll do this is b naught, a naught, c naught. So b naught equal minus 2a, c naught, a naught equal 1 plus a square, c naught equal 1 minus k. Now we'll apply b square minus 4ac. B square mean b naught square mean minus 2 square minus 4 times a mean 1 plus a square, c mean 1 minus k equals 0. Now we have to solve this one. Sorry, not equal to 0, greater than 0. So this is 4a square minus 4 times, and this is going to be 1. I am multiplying these two together. 1 times 1, 1, 1 times k minus k. This is a square times 1, a square. This is going to be a square minus k, a square greater than 0. Now I'm going to take from minus 4 out. 4a square minus 4 plus 4k minus 4a square plus 4ka square greater than 0. So minus 4a square, this is cancelled out. Now I have minus 4 plus 4k and 4k a square greater than 0. So I can take 4, I can send to other side. So it is going to be 4. From here I'll take k out. Then 4 plus 4a square. So then 4 over 4 plus 4a square, because I can bring without changing the symbol, because for any a value a square positive. I divide by both sides from this one, because a can be any number, but a square is greater than equal to 0, so a square plus 4 greater than equal to 0. So on that basis, plus greater than 4 greater than 0. So on that basis, so k 4 times 4, 1 plus a square. So this is cancel out 1. K greater than 1 plus this one. Actually, here when you look at, I did notice that the 4 is common. So since 4 greater than 0, I can divide inequality by 4. Then this become a square minus 1 minus k plus a square minus k square greater than 0. Then a square minus 1 plus k minus a square plus k a square greater than 0. This is cancel out. Now this is when I take from here 1 plus a square to other side 1. Now k greater than 1 over 1 plus a square, you can divide, because a can be any number, but a square greater than 0 equal to 0, but a square plus 1 greater than equal to 0 plus 1, which is greater than 0. That's why a square plus greater than 0. That's why we will be able to divide without changing the sign. Question number 19. Prove that this one is touch the tangent to the given circle. So if it is a tangent, it means it is touch. Then it has one solution. If it is not tangent, it means we have two solutions. So it is not the touch, there is no solution, or there are two solutions. So if there are two solutions, it's not a tangent. No solution is not a tangent. If there is only one solution, then it is a tangent. So this is the argument we want to. So first of all, um, so we have to solve these two equations. So first of all, I'll find the value x plus 4 square plus y minus 3 square equal 100. So we'll make y as a subject or x as a subject. We can work anything and substitute here. So I'm going to make y as a subject. 4y equal 3x minus 26. Y equal 3 over 4x minus 26 over 4. Now I'll substitute here x plus 4 square plus y mean what? 3 over 4x minus 26 over 4 minus 3 over square equal 100. X plus 4 over square plus, this is going to be minus 26 minus 3 over 3 minus 26, 12 over 4 minus 39 over 38 over 4 minus 19 over 2. So 3 over 4x minus 19 over 2 square equal 100. Now I have to square this one, x square plus 4 times x, 4x double 8x plus 16. This is 9 over 16, 4 square, 16x square plus, okay, minus 2 times 3 over 4, 9 over 2, 2 to 2 cancel out. This is going to be 57 over 4, so minus 57 over 4 x, then 19 times 9, 361 over 4 equal 100. So this is going to be 1 plus 9 over 16 x square. So this one done. So this is 8 minus 57 over x, and this is 16 plus 361 over 4 minus 100 equals 0. This is going to be 25 over 16 x square. This is going to be 32 minus 57. Best thing is to multiply by 16 and get rid of this one. So this is going to be 16 x square. This is going to be 128x, and this is 16 times 16, 256 plus 9x square, 57 times 4, 228, and 361 times 4, which is 1444 equal 1600. So 16x square, 25x square, this one, and 128. This is x. This is 128 minus, this is going to be minus 100x. From those two, and this calculation is going to be to this plus 100 equals 0. So divide by 25. This is going to be x square minus 100x minus 4x plus 4 equals 0. So this is going to be x minus 2, the square equals 0. So it means x minus 2 equals 0, or x minus 2 equals 0, x equal to, or x equal to only one answer. Hence, there is only one solution to the equation. Hence, 4y minus 3x plus 26 equals 0. T touches the circle. Question number 20, you can see that we want to show that a square plus b square equals a square. So this is a equation. So you have to make a equation. How do you build up the equation? Because there is one similar way doing it. If we have a equal to b, okay, I write different symbols. A equal b and a equal c, then you can write b equal c. What is happening here? One thing we express in two ways. A expressed in b's way, A expressed in c way, then but both are same thing. Because of that, b equals c. So we want to look at this kind of argument now. When I look at, I will get, I can see a white square. So white square is, I can write, it is area. Okay, we'll go to area of white square is c square. Then area of white square also you can write there is an area, the big square. So that is something like this. So this is A and this is going to be, this side is A plus B. Then this whole length is, whole area is A plus B square. Whole area. And we want to minus 4 rectangles. Sorry, 4 triangles, right angle triangles. So this is A, this is B. Then one triangle size is half a AB area. Likewise 4 times. So you have to take 4 times half a AB. So now what will happen? We express the same area of white square C square, same area of white square differently, whole square minus 4 triangle. Hence what you can tell, a plus b square minus 4 divided by 2ab equals a square. Now we made the expression, so equation now. Now we have to solve and we have to check whether we are having this similarity. So I'll expand this one: a square plus 2ab plus b square minus 2ab equals c square. This is cancel out. A square plus b square equal c square. So I express this white area in two different ways. Simply we can find this is c times c square. Then the same area you can find from, we can minus from full area minus 4 triangles. I'll show this one differently as well. Assume I'm going to consider this area. This area mean I'll PQR. So area PQR mean half a AB. Also area PQR you can find, right? Whole area A plus B square, then minus this one minus C square. Right, then we get 4 areas. Whole areas minus this one, then 4 areas. We need 1 area. Divide by 4. Now still you can equal this one. Half a AB equal A plus B square minus C square over 4. First multiply, this is given by 2AB equal A plus B square minus C square. So we'll bring this one, C square equal A plus B square minus 2AB. So I bring C square to one side. This has to be A square 2AB plus B square minus 2AB. This is cancel out. And C square equal A square plus B square. We'll equal again differently. So area of PQR equal, and this PQR area is half a AB. This is AB perpendicular distance. Also area of PQR I can write whole area A plus B. This is A plus B square whole area minus this white square C square, and then I get 4 triangles. I need 1 triangles divided by 4. Then I can make equal to this one. A equal B, A equal C, B equal C. Half a AB equal A plus B square minus C square over 4. Then cross multiply 2AB equal A plus B square minus C square. Then I'll bring to this side C square plus B square minus 2AB. Then A square 2AB plus B square minus 2AB. C square, this is cancel out. C square equal A square plus B square.